or to facilitate the let's say the dissemination of technology and enhance the contribution of science and technology in overall agriculture development. Mostly we have agriculture economists working here, and we are part of the Indian Council of Agriculture Research. So it's a large family. We have more than 100 research institutions, and then some more, let's say the field science centers. But we are engaged mostly in agriculture policy research. But we work with the other institute of ICR and State Agriculture University. They are multi-faculty universities, so we work on that. But we were trying to understand the application of space science in agriculture. And we have been trying to do for, let's say, the few years. We had a small project earlier, but we started that. But then I moved to some other place, and it was given to ISRO. I don't know how much they have interaction with ISRO or maybe your institute. But recently, there is a lot of emphasis in the Ministry of Agriculture to have some kind of real-time information or monitoring of agriculture situation, how we can use the space science for collecting these kind of, you can say, the real-time data. Say, for example, ministry is coming out with some kind of crop forecast. They have a small center there. They are using the this remote sensing kind of the technique, but still that is not perfect. They just basically tell, yeah, this is the status of crop growth. But I think a lot of advancement has been taken in terms of mapping the natural resources. What is the condition there? How much, let's say, water resources they are available? What is the growth situation? How much sowing has taken place? And including the risk management, disaster, all those kind of things. In fact, once somewhere somebody said that the trajectory of development in any country is basically determined by the space science. Who is dominating the space? So that will basically influence the development of science, and development of science and technology will further facilitate the overall development, including the agriculture development. So therefore, there are a lot of applications, but we being away from the ISRO and the other institute, we are not able to take full advantage of the expertise is available with ISRO and the institute like which you are heading. So therefore, today we are, thank you in fact profusely for giving your time, and look forward to benefit from your expertise, how we can do it and what kind of linkages we can establish if you want to have a research program. Say we are given another responsibility that we have to come out with some kind of short-term crop forecast or some kind of assessment of agriculture situation using AI and other kind of advanced data. And there we require a lot of this remote sensing kind of images, those techniques. So how we can use those techniques or the technologies which ISRO is having and the expertise, of course, and apply for assessment of agriculture situation. So definitely we are going to benefit from your wisdom. But for the benefit of my colleagues, let me take another minute or two to introduce our speaker, introduce to you. Of course, the kind of work which you have taken, it will be very difficult for people like us who have little understanding of science, particularly the space science. But let me try a little bit the work which you have done. So friends, Dr. Prakash Chauhan, he's basically a man of physics. Dr. Prakash Chauhan obtained his postgraduate degree in applied geophysics from the Institute of Technology, IIT Roorkee, and PhD in physics from Gujarat University, Ahmedabad. Prior to joining Indian Institute of Remote Sensing, IIRS, what we call in short form, Dehradun, he was group director at Space Application Center of which is part of ISRO in Ahmedabad since 1924. That is, I guess, sir, your main institute, Space Application Center.
Yes.
He joined Indian Space Research Organization, that is what we call ISRO, in the year 1991 as scientist, and since then working for the application of remote sensing technology for natural resource management for ocean and land resources. He initiated research activities for planetary remote sensing at Space Applications Center to study solar system objects, mainly Moon, Earth, Mars, through Indian planetary missions. From April 1st, 2020 onwards, he is also holding additional charge of Director CSS team. So he has wide experience, and not only within the country, outside also, he is having a lot of interaction, participation, and most importantly, there are a number of things, but I would like to bring to notice of my colleagues that he is part of as a member of the NASA ISRO Science Working Group. So that is, I think, very prestigious group, I think, and he is a member of that. And he has been associated with the Chandrayaan-1, Chandrayaan-2, and all other the missions, space missions involved, and Earth observations, and then these ocean observations. He has been, participated in those programs, and these are the areas where at AXA we have a lot of interest. He has received a number of awards from his organization, ISRO, as well as the Society, Indian Remote Sensing Society, and there are a number of Dr. Vikram Sarabhai Research Award, ISRO Merit Award by Indian Space Research Organization, Satish Dhawan Award by ISRO Society, and he is also fellow of the National Science Academy. So he has very, I would say, the very recognized career, distinguished career in the field of physics, application of physics and space science. So we have very distinguished visitor, and we are going to benefit from his experience and the lecture which is going to deliver. So Dr. once again, thank you very much for your time. And we look forward to listen to you, because we want to give you as much time you want to take. Thank you, Dr. Thank you very much.
Thank you, sir. Thank you for your kind words, sir. Thanks a lot for inviting me for this important occasion as well. So, madam, can I share my screen?
Yes, sir. It's coming. It has come.
Yeah. I hope you are able to see in the full screen mode.
Yes, sir.
Perfect. That's a perfect. Yeah.
Thank you. Thank you, Director of National Institute of Agriculture, Economics and Policy Research. Thank you very much to Madam Rajni Jainji and all the colleagues today, those who are joining this webinar on this great occasion when we are celebrating the 75th year of our freedom. And very aptly, this has been termed as Azadi Ka Amrit Mahotsav. I have been honored and privileged. It is my privilege and honor to be part of this celebration for your institution. And please accept my greetings from Indian Institute of Remote Sensing, which is part of Indian Space Research Organization located here in Dehradun. So as Director Saab has just told that your institution, National Institute of Agriculture, Economics and Policy Research, is a very important institution which is generating a lot of data on the agriculture statistics. And based on the data sets, the data sets are the most important thing for policy framework, especially for an important field like agriculture, where which is contributing more than 16% to the GDP of this nation and employing more than 50%, around 55% directly and indirectly the population of this country. So in such scenario, not only we talk of the agriculture activities which are being done on our land, but when we talk of agriculture, we also include, the resources, especially the living resources coming out from our coastal waters and oceans. So in that sense, the economic value of these resources are tremendous. And considering the kind of population we have to support, this activity is very important in terms of food security of the nation. Now, coming to the topic of today's discussion, where you have asked me to talk about how the space technology, in particular Earth observation, or what we call as remote sensing, is being used for agriculture-related activities. I will be mainly focusing on this aspect, but today the remote sensing information is being used on, virtually you can imagine any field of activity, human activity, it is being used. Let me confess to begin with, I am not an agriculture specialist, but I have a good knowledge, or a relatively good, since I have worked almost for 3 decades about remote sensing and space technology. And with my association with my friends, those who come from agriculture background, and I have spent around more than 2 decades at Space Application Center, where the activities related to agriculture remote sensing was initiated. I have learned little bit, so I will try to do justice with this subject. Now, as far as the Indian space program is concerned, many of you are aware that, as Director Sab told, space program of a nation is an indicator about the S&T ecosystem in that nation. And space is considered to be the last frontier in terms of technology. And I am happy to inform you that India is one among the leading, spacefaring nation in the world, and ranked within the top 5 countries at this planet Earth. The program got initiated somewhere in late 60s with the vision of Dr. Vikram Sarabhai, who is considered to be the father of Indian space program, with a vision to harness space technology for national development while pursuing space science, research, and planetary exploration. So, at one end, we are looking to enhance the knowledge of humans, especially about the solar system and the outer solar system objects, even about the universe and stars formation, and to gain knowledge about different galactic processes. But at the same time, we are keeping a strong eye on our own planet Earth, and especially on our own country, where we are trying continuously that how we can harness the use of space technology for the benefit of the common man of this country. Now, space activity in this country, as I show in this chart, is spread across the length and width of our nation. We have a lot of institutions in the south. We have Vikram Sarabhai Space Center, which is the launch hub. Most of the the rocket systems are being developed here. There are another institutes like Liquid Propulsion Center. They are basically expertise. They have expertise in developing the engines for the rockets. And then we have this spaceport at Sriharikota, from where the rocket launch, which carries different satellites. The activity of launch is carried out from Sriharikota. At Bangalore, ISRO is headquartered at Bangalore, as well as we have multiple institutions. The main is URO Satellite Center, where most of the satellites are being constructed. Then, of course, we have at Space Application Center large amount of activities, including development of the sensors, which are basically like eyes to a satellite. Sensor technology, both optical imaging as well as in the microwave region, as well as the communication instruments are developed at Space Application Center, along with data processing capabilities. And of course, the use of these data products methods are also developed at SAC. Then we have a lot of other small entities. In Delhi, we have presence in administrative office. At Dehradun, we have Indian Institute of Remote Sensing, which is an educational arm of ISRO. My institute is mainly is devoted towards capacity building, training, and education in the broad field of remote sensing and geoinformation science. And then we also have presence in the Northeast in the form of Northeastern Space Application Center. So as you can see, the activities are fairly widely distributed, and throughout the country we have the presence as far as the Department of Space is concerned. There are 4 major verticals in which you can divide the space activity of the country today. We have a broad field of satellite communication. So many of you are aware about the use of satellite communication, the entertainment channel through direct to home services like Tata Sky and many other operators which you receive at your home is basically being run on the satellite based communication system. So many satellites are there at at an altitude at around 36,000 kilometers, where we have these orbits which are known as the geostationary orbit, where the satellite appears to be stationary with respect to the motion of the Earth. And these communication satellites are developed by our country, as well as some of the hard services are also being used within the country. Then, of course, the second vertical is for the Earth observation, where we have satellites having capability to view Earth at different spatial resolution. That means the satellite images will have varying resolutions, maybe from less than 1 meter going all the way up to 1 kilometer. Depending on the nature of the application, one can select the resolution of the images and variety of resolutions in different parts of electromagnetic spectrum are available today as far as the ISRO sensors are concerned. Then, of course, we have this very important field which is emerging, is satellite navigation. So many of you must be using global positioning system, GPS, for various activities. Even in a city like Delhi, if you have to navigate. Yesterday I was in Delhi only. So for an outsider to go from one bhavan and to go to some other bhavan and other places, if you don't have nowadays the Google navigators, it's almost impossible. So all these location-based services, the food delivery boys, the pizza delivery boys, all of them are using space technology in terms of positioning systems. India has also developed its own regional, global positioning system called IRNSS or NAVIC, which has been termed as NAVIC by our Honorable Prime Minister ji. So this is also a very important component of the space activity. And the fourth and very interesting component is the exploration of the outer space, especially understanding more about our own star, which is Sun, which is driving our solar system. Then, of course, other planets in solar system. And then we also have satellites like AstroSat, which are basically also giving a lot of information about various galactic processes, including the formation of stars and the different processes through which the star in their life undergoes in different wavelengths. So these four verticals, if you have to send these satellites in different orbits around Earth, or or around other celestial bodies, like we have satellites currently orbiting around Moon as well as around Mars, you have to have a launch vehicle program. That means you have to have a capability in the country to launch these satellites, which basically range in sizes and in mass from your own soil. So in all these five aspects, I am happy to inform this August gathering that over the last 50 years or so, since the inception of Indian space program, India has achieved total indigenous capability with the hard work and dedication of our scientists in this country. And today we need not depend on any external sources for carrying out these activities for the development of the nation. Now, the most important aspect, having technology is one thing, but how we can use this technology is also equally important. If you don't use the technology, it's not going to give benefits to the common people, and its sustenance will be questioned. So today we have developed an equally vibrant space technological application program, where we are using these space technological elements, which just now I described, for various sectors like agriculture, forestry, fisheries, drinking water assessment, natural resource inventory. The snow and glacier in Himalayan region is very important to, for the water security of the nation, as most of the North Indian rivers, they originate in Himalaya, and they are strongly dependent on the snow cover and the health of the glacial systems. Similarly, in areas, all of you are aware, India has a lot of, agriculture dependency on the rainfall. So rain-fed agriculture is also a very important component. For that purpose, in states like Western states, especially like Maharashtra, Gujarat, and Rajasthan, large amount of activity on watershed development is being done, and space technology is playing a very important role in identifying the locations where the watershed development program can take up. In the place, in case of urban planning, weather and climate is also very important, as all of us are aware. And today we have two meteorological satellite systems operating from 36,000 kilometers and providing weather information every 15 minutes to India Meteorology Department, and they're assimilating this data in the weather forecast model. And you must have seen that over a few years, the weather forecast accuracy in India has enhanced significantly thanks to modeling skills as well as the data availability from space-based systems. And then, of course, host of communication applications like news services, DTH, disaster management related aspects, and of course the location-based services. Now, if we assess today what are our current assets in space, so we have host of communication satellite systems like INSAT and GSAT series of satellites. Satellites having more than 250 transponders in different frequency range. I will not go into details of that. Then we have these two geostationary satellites, which just now I spoke, which is providing information on the weather. And then we have this low Earth orbit satellites, which are normally known as the polar satellites. They go from pole to pole, and they orbit in an altitude somewhere between 500 to 800 kilometers. And these are all classically being used for what we call as the remote sensing satellites. So a couple of them, various thematic series of satellites, like for resource assessment, for ocean studies, for cartographic and mapping studies, for generating digital elevation information about the terrain. And then, of course, also to study various elements of the ocean. We have a variety of satellite systems which are orbiting Earth today. And of course, this I talked about the regional constellation, which is known as NAVIC, where 7 satellites are there in the space, 3 in GEO and 4 in GSO, what we call as the geosynchronous orbit. And then, of course, currently as we speak, we have 3 satellites. One is going around Mars, our Mars mission. Many of you must have heard about it. There are movies which has been made about the Mangal mission, and this satellite is still working. And then we have another satellite. You must also heard about Chandrayaan-2 mission, which was launched 2 years back. One of the components of that mission was to land on the surface of Moon. However, we still have our orbiter going around the Moon surface and providing a lot of information and data about the Moon surface. And then also we have this multi-wavelength AstroSat satellite, which is basically being used for astronomical studies by a lot of astronomers in the country. Now, if you talk about the history of, especially since we will be talking more in this talk about the Earth observation satellites, if we talk about the historical evolution, we made a very humble beginning somewhere in 70s or late 70s when we had this first satellite called Bhaskara, which was an experimental satellite system. It provided very coarse, images, and then systematic efforts were done to build this remote sensing program in the country. And in fact, let me tell you a very interesting story. The entire premise or the basis of remote sensing program also started with horticulture or agriculture applications. Many of you must have heard the name of Pierre Pesharuti, who was a famous meteorologist. So he started or initiated research activity in the broad field of remote sensing with aerial photography. So we had, this color infrared aerial photography in those days. And the first experiment was conducted in Kerala over the coconut, groves. So coconut have this disease, often it, spreads into this coconut trees. It's called coconut root wilt disease, and it affects the crown of the coconut trees. Now, the task was given to this team to identify using an aerial survey the trees which has been affected by this coconut root wilt disease. So color infrared photography, both in the visible as well as in the infrared range of electromagnetic spectrum, was carried out using an aircraft-based survey. And based on that data, the trees which were affected by this coconut root wilt disease were identified simply because a healthy tree will have a lot of light reflectivity in the infrared region compared to a tree which is diseased and have less pigments, especially the chlorophyll content in the leaves. So on the basis of this experiment, this became the basis, or you can say the first experiment in India which proved the utility of remote sensing, especially in the field of agriculture. So we can give credit to the broad field of agriculture and horticulture to give what we call as the excitement about this technology, and the planning for a satellite-based system really kicked off from such kind of experiments. Then, in 1988, we launched our first remote sensing satellite, which was known as IRS-1A, which was followed by the similar satellite called IRS-1B, and it has a special resolution of two varying capabilities, 36 and 72 meter spatial resolution, with a repeativity of around 22 days. So over the same reason, the satellite will come after 22 days, and again it will capture images at a moderate resolution called 36 meter, and then another camera at 72 meter with different swaths. Then, of course, we have never looked back in time, and then we kept on improving on our imaging capabilities. And in 2003, a first resource satellite dedicated to the natural resource management and mapping was launched. And basic purpose of this satellite was to keep an inventory of agriculture as well as the other vegetated systems, especially the forests, the coastal forest, mangroves. Even it was used for coral reef mapping, and then of course also to identify wasteland in the country, and of course periodic and repeated survey of various agriculture dominated regions in our country. With this satellite system, we developed what we call as a 3-tier imaging capability. That means same area we can view in 3 different spatial resolution, from 6 meter spatial resolution to 56 meter spatial resolution. I will show you the examples and the advantages of this 3-tier imaging in the subsequent slides. So what this satellite data did, that it opened door for many applications, especially in the agriculture sector, for doing rapid crop assessment and crop surveys. Then, of course, we also had this series of very high resolution satellites having spatial resolution better than 1 meter or of the order of 1 meter, mainly meant for the for urban and rural planning purposes, where you can see the object very clearly, large in size, as well as using a satellite system called Cartosat-1, which has the capability to view the Earth's surface from 2 different angles. One can also derive what we call as the digital elevation map model, or the topographic information. So not only the 2-dimensional information, but 3rd dimension in terms of height. And this data is very useful, especially in mountain regions, and for doing large amount of site suitability studies for horticulture crops. As you know that most of these horticulture crops in mountainous regions, they have preferential slopes and aspect. Mainly the south-facing slopes, which will receive more sunshine, they are basically good for certain crops, and certain horticulture crops, they grow in the mountain shadow region. So using this topographic information, and the other satellite data systems, I will show some examples where some of our friends have done work on finding out site suitability for various horticulture crops in mountain climates. And then, we had developed today the capability to image Earth at kilometer scale spatial resolution to less than 0.5 meter now with Cartosat-3, and with varying temporal resolution. That means the advantage of satellite technology is that if you want to repeat the observation, and especially it becomes important in in fast growing, environmental situations like crops, where you have a crop calendar of around 2 to 3 months, and you would like to do multiple surveys over a particular cropped area. So in that scenario, the satellite observations are very useful, because large area repeated observations can be done in a very fast turnaround manner. And compared to ground-based surveys, these surveys are relatively inexpensive. And of course, we also have a term called spectral resolution. Don't worry about it. It basically gives a satellite sensor a imaging capability in certain regions of the electromagnetic spectrum, like blue region, green region, red region, infrared region, because many of these regions, see, our eyes are sensitive only in the visible part of electromagnetic spectrum from 400 nanometer to 700 nanometer, but crops especially and the vegetated systems also have very unique signatures in infrared beyond 700 nanometers. So especially what we call is the near infrared, around 800 to 1000 nanometer range. So we can devise sensors which can look in this part of the electromagnetic spectrum, which is not sensitive to our eyes, and we can get very sensitive information about crops, especially about the chlorophyll A concentration, about different type of pigments, and about the water stress also in the plants. This is something to tell you about the journey of Earth observation systems. And today, as we speak, we have this suite of satellites currently available from space. As I talked, we have a next generation of ResourceSat satellite. It's called ResourceSat 2. And we have two such satellites operating from space called ResourceSat 2 and ResourceSat 2A, with this concept of 3-tier imaging, having images in 56 meter, 23 meter, and around 6 meter spatial resolution for same area in different, revisit capabilities from 3 to almost 2.5 or 3 days to 11 days. We can make assessment about these vegetative systems using ResourceSat 2 data. And of course, I talked about this CARTO CT series of satellites, which are basically meant, which are very high imaging satellite systems meant for cartographic applications. There is another technology which is known as the microwave imaging technology. See, the limitation of this optical imagers, which work in the visible and infrared part of electromagnetic spectrum, that they cannot see the Earth's surface when there are clouds in the skies. So especially during Kharif season, where we have crops like rice, which is a predominant crop, and we need to know the status of the rice transplantation and the amount of crop in different states at different scales, like starting from, let's say, village to taluka to district state. So this becomes a problem from optical data, because this cloud cover hinders the visibility in the optical instruments. So there is another wavelength region available to scientists. It's called the microwave region, where the wavelengths are, the wavelength of the energy is much longer, and it has the capability to penetrate the cloud. And since many of these microwave imagers, they also carry their own source of energy, like a torch which we use in the night. These systems can also operate even when there is no sun. That means in the night time also we can do imaging, and in all, that's what is known as all weather capability, morning, evening, afternoon, anytime, and whether clouds are there or no clouds are there. Microwave remote sensing systems are very useful and extensively being used in this country, especially for rice mapping. I will show you some examples of that subsequently. Similarly, oceans are also important, and ocean are also a rich source of living and non-living resources. And especially when we talk of living resources, the basic food chain in ocean starts with the phytoplanktons, and they are the autotrophs. Like we have the plants which are autotrophs on terrestrial systems. In aquatics and marine system, the phytoplanktons are the autotrophs, and they form the food chain, the basis of at the bottom of the food chain. And we have the capability today from space to map this phytoplankton concentration in the upper column of the seawater based on the central principles of physics, where the interaction of light with this chlorophyll A pigment can be picked up. As many of you may be aware that chlorophyll A pigment absorbs very strongly light in the blue and the red part of electromagnetic spectrum, and it reflects in green. That's why the plants look green. So using very specialized sensors, one can also make estimation of aquatic planktonic productivity or the biomass turnover in the aquatic systems also, which can be further linked to primary, secondary, and tertiary productivity in these systems. And an assessment about the marine living resources can also be made by these ocean satellites. And of course, these weather satellites, I just informed you about that. So today, the data from these satellites we are using for all kind of natural resource census, including minerals also, agriculture crop inventory, wasteland mapping and changes in the wastelands, watershed development, forest mapping, biodiversity mapping. So today, Forest Survey of India, every 2 year, biannual forest survey is being conducted by Survey of India for entire country, and they are producing what we call as the state of forest state report. There is a term for that, I'm forgetting. So essentially, every 2 years it comes out with the statistics on the forest cover over India using primarily the remote sensing based surveys. Of course, we also do a lot of inventory of surface water, because we have large reservoirs in this country and big natural water bodies, and the surface water, surface water availability in these water bodies will be changing in time and space and in seasons. Especially during summer season, it becomes very critical at certain places. So satellite data is being used for monitoring these surface water bodies for irrigation and for potable or domestic use of the waters in these big water bodies. And of course, for command area monitoring, especially for irrigation infrastructure development, reservoir capacity evaluation. Many of the old reservoirs, they are getting filled with sediments. So sedimentation is a big problem in reservoirs. So we have the capabilities to estimate reservoir sedimentation and how it affects the reservoir capacity over a period of time. Snow melt runoff is another key area. We have a lot of area in this country under wetlands. And these wetlands are really under threat in India. Many of you must have seen a lot of urban wetlands, especially around the big cities, wherever there used to be talabs or talavadis or small, ponds. Most of these ponds or the wetland systems in our urban environment are vanished. In fact, many of them have been reclaimed, and a lot of people are living in these areas, which are reclaimed areas. Big, towers and flats have come up, and that has changed the hydrological properties of the surface, especially in the urban environment. And you must be seeing that a lot of frequent, urban floods are happening. And one of the reasons for urban floods, of course, there are other reasons also, but one main important reason of large amount of urban flood and their higher frequency in Indian cities is that we have, very badly managed the urban wetlands in this country, and a lot of problems are being faced because. So we have, developed a very nice national inventory on wetlands using high resolution, moderate resolution satellite data, and this is being updated now. This was done in 2006-7 timeframe, but now this new wetland inventory is also about to be released. We also have a very good statistics on the mangrove forests, coral reefs, which are very important, very fragile ecosystems, as well as the coastal land use maps of this country. Drought disasters are also, India is a highly disaster prone country as it is a continental scale size country. Various kinds of natural hazards hit us, but the hydrometeorological hazards, their frequency is very high every year. So especially the floods, I talked about urban floods in the rural areas. Then you have this, intense rainfall events are also picking up. They are causing a lot of damage to agriculture as well. We have hailstorm situations. We have cyclones in coastal areas, which also brings large amount of rain, and a lot of area gets inundated. And especially, we need to make an assessment about the crop damages aftermath of a cyclone. So in all such scenarios, remote sensing data is currently being used today in the country. And of course, in urban development, there are a lot of schemes where data is being used for urban planning and then infrastructure development activities. I'll not go into details of many other things because time is less. So what I told in just now, essentially in terms of slide, we are now using satellite data for food security of the country, for crop acreage production estimation, crop condition assessment and yield modeling, agricultural drought assessment, horticulture development, soil salinity and alkalinity mapping. This is also a very important aspect because the soil sciences or the soil scientists are now in a position to use satellite data. In fact, in UP, a large project was done with the help of satellite data where the sodic land in the UP has been reclaimed. Initially, the sodic land mapping was done, and then the chemical interventions were done in these sodic lands, and now large amount of area with the World Bank project, it was a big project, has been reclaimed in state of Uttar Pradesh as far as the soil salinity and alkalinity remediations measures are concerned. Water is also very important. Food and water, these are the two aspects or important aspects of sustainable development goals which we have to achieve by 2030. And water resource information system is available India Varis now from ISRO and currently being operated by Central Water Commission. We also have a big program called Rajiv Gandhi Drinking Water Mission Program, where the groundwater prospect and recharge map has been done for the entire country. We are also doing a lot of work on irrigation and command area statistics in generation, National Remote Sensing Center, NRSC, and other institutions of ISRO are having a lot of activity in this aspect of reservoir capacity, watershed, etc. Others are especially in terms of environmental and ecosystem assessment, forest cover. I talked biodiversity also up to some certain extent at land scale and community level. These type of biodiversity studies are being done. Desertification, natural resource sensor, grassland productivity. These are some of the key issues in terms of ecosystems. And of course, for disaster, I just spoke about flood, and then landslide hazard, forest fire, where we are providing regular information to the stakeholders. And of course, in case of assessment of aquatic and marine resources also, a lot of work is happening in this country where the space technology is playing an important role. Now, coming specifically to the topic which you asked me to speak. So as you are aware, the Indian agriculture has a significant diversity, starting from J&K and going all the way to Kanyakumari and from Gujarat to Assam. We have different agrometeorological zones, and this diversity is primarily driven by the diverse nature of precipitation in the country. So if you see, we receive large amount of precipitation in the eastern part, but as you come through, go from east to west, the precipitation dwindles, especially in states like Gujarat and Rajasthan. So that also affects the crop practices in these areas. We have a very large area, almost 44% of our geographical area is under net sown area, which is approximately 141 million hectare. This year, 2021 food grain production, bumper food grain production, the farmers of this country has done is around of the order of around 308 or 309 million metric tons. We are also a big producer of horticulture crops. We have a good amount of area out of 141 million hectare. 66 million hectares is around net irrigated area. And of course, this activity in terms of economics is so significant that we have seen the importance of agriculture during these difficult years of COVID, where this was the only sector which was basically rated in the positive GDP contribution since these 2 years compared to the other major sectors of economy. So the agriculture still in India is the backbone, even though they say that if you want to attain, the status of a developed country, if you see them, the contribution from the agriculture has to be minimal in those countries. But in case of India, the kind of diversity and the rural population we have and our dependence on agriculture, we cannot ignore this sector. This contributes almost 16 to 17% to our GDP and provides employment to more than around 55% population of the country in direct and indirect manner. And if you look, this map is the global agriculture map. We have an initiative with our friends in the United States America and with other colleagues. It is called GeoGlam, Global Monitoring of the Global Agriculture Monitoring. So this GeoGlam initiative also uses satellite remote sensing for inventorying and providing the condition assessment about the crops on a global scale. So this is the global crop map. So you have this large agricultural tracts in United States of America, then of course in Brazil and in Argentina, then of course this Russian territories, and then China. But if you see in terms of the this green and yellow, which is also telling about the condition in that year, large amount of area, as a country level, is under agriculture when you compare to the other big countries of the nation. So these are the prominent agriculture or the food producing regions of the world, and India is almost is a central to all these global players in terms of agriculture productivity. So India is ranked, their rankings are also pretty high. I will not tell all of you, it's known to you. So today we are using this earth observation data for different sectors of agriculture. Agricultural land monitoring, crop area estimation and production forecast, agriculture drought assessment and monitoring. Let me inform you at this time, maybe a few more slides will come. So we have a new drought manual, which has been supervised and cleared by Honorable Supreme Court of India. And now, all of you are aware that drought declaration used to be a very politically sensitive issue in this country. But with the interventions of various agencies, this new drought manual makes it mandatory for agencies to use satellite remote sensing data of what we call as the normalized difference vegetation index, NDVI values, and then other soil, water availability. So combining multiple parameters, now it has become mandatory to use remote sensing observations for declaration of the drought. So this is what is the contribution today. The space technology is playing a role where for a sector for drought declaration, where financial incentives are available for different states at different district levels. This technology has gone at a very deeper level. Then, of course, certain examples I will show. See, we really did not have a very systematic inventory of horticulture crops at a national level in this country. And an initiative by Ministry of Agriculture and Department of Space, we had run for, still that activity in phase 1 and phase 2 was run, and which is going to be completed this year end, where the space technology has been taken up in a certain number of districts in the country to provide first-hand, large-scale inventory of horticulture crops. Of course, it is limited for certain crops only, but that is a new information which has come up. Then, of course, cropping systems are also very important aspects. Crop rotation also is very central theme for various issues which are cropping up, like carbon farming and then carbon sequestration issues and carbon credit issues. Then, of course, as I told you, we are also contributing, India is also contributing significantly to this global agriculture monitoring initiatives. Water, Dr. talked about it. Water availability is very important for agriculture, soil problems, pest and disease, and of course, fisheries. So all these sectors, which are very important sectors, there is a role of space technology today. And not only the government institutions, but today large amount of startups and the innovative technology developers are coming out with new solutions, either which are space based or UAV based or aircraft based, which are getting into what we call as the digital agriculture scenario. In fact, Government of India has a big emphasis on what we call as the digital agriculture, and they would like to have most of this data, both not in tabular form but in a geospatial form, about the various aspects of agriculture and allied sectors in our country. So as I was telling you, we have this imaging capability today at different resolutions. So all these things which you see in this image is in red color. So the remote sensing scientists, they call these images as false color composite, because why it is called false? Because the colors are assigned in a false manner. You have natural colors, red, green, blue, but here we are giving red color to infrared imagery, and then green and blue are assigned to red and the green part of electromagnetic spectrum. And this combination produces this red zones which you are seeing here. If you are not a remote sensing specialist, don't worry about it. All these red features which you see at different scale, see, this is at 56-meter scale, where you can see the state-wise distribution of these crops, red in color, especially in Uttar Pradesh over here. This is river Ganges, this is Yamuna, and then this is Hoshangabad, the area of Madhya Pradesh, which is a major wheat growing region. Then you have this 23-meter resolution, where the information increases in terms of spatial resolution. And then you have this 5-meter or 5.8 or 6-meter map, where you can start seeing the individual fields, where the different type of crops and even fallow fields are also start emerging. And then you have
the slide is not moving now.
Yes, sir. Your slides are not moving. You maybe you have to share and share. Yes.
Now, can you see it again?
Yeah, yes, it is coming.
Yeah. So what I was telling you, at different scales for regional assessment, for district level assessment, and for farm level assessment, all these red color fields starts appearing when you have a spatial resolution of around 6 meters. So you can also see the fallow lands and the diversity in the field also. And when you go to the 1 meter spatial resolution, you can start seeing the individual trees also, especially in an area which is, let's say, plantation area, or trees around the boundaries or periphery of the farmers' fields also can be, the inventory of trees also can be done. So this is the role of resolution. So if you want to have a regional level assessment, let's say state level assessment, you can use 56-meter resolution data, which is very good for generating national level inventory. But if you want district level or sub-district level, then you have to go to 23-meter resolution. And if you are interested in block level or at village level also, then you have to have very high resolution data. And of course, for horticulture or plantation, inventorying, you have to have 1 meter kind of spatial resolution data. Remember, as you increase the size of the images, the volume, the area, either you have to reduce the area, or if you want to cover the same area, the volume of data becomes a large issue. And nowadays, new advanced technologies are being developed, where a user need not have this data at your desktop. There are cloud-based services, which are basically very important. There are cloud, dedicated cloud services like Google Clouds are there, then Amazon Cloud are there. India is also developing our own cloud. That means you can go to this cloud service where digital data is residing. You do your analysis and only take your results to your computer, and don't worry about downloading this, terabytes of data to your machine. So these are the new innovations which are happening, especially in terms of digital agriculture and digital agriculture informatics, where techniques like as Dr. told about artificial intelligence, machine learning, as well as the cloud-based services are becoming very important. So you have the information content, but how to harness this information content for your objectives. Depending on your objectives, you can choose your problem statement and address those problem statement. What I show you here, the power of temporal observations. So this is Punjab state over here, and these are different districts. So you can see there is a lot of red color in the month of January, because it's the peak season for the Rabi crops, especially you have wheat and mustard in this area, and then predominantly, then you go to in February, where you see that the crop is really matured now, the vigor is very strong. And then as you start coming into March, you are at the late stage of the crop, and then by April, in different districts, depending on the sowing dates, etc., the harvesting starts happening. And by May, most of the area is harvested. And of course, you can see that the area becomes fallow. And of course, there are a lot of horticulture things in these regions. But predominantly, the entire cropping cycle can be monitored if you acquire images at different stages of the crop stage of the crop growth. So this is that basic concept of 3-tier imaging. That same area we are observing at a coarse resolution. Then we are narrowing down our search to 23 meter in that same sector, and then going to very high resolution like 6 meter or so. So we can sample this entire area at different, sampling interval, as well as with different sample sizes, which provides opportunity to take up surveys at different geographical scales. So this is how the images looks. Earlier I showed, but I show you details. All these red areas at 55 meter resolution, they are the crop parcels. And this is the major reservoir, Gandhi Sagar reservoirs in, this is Madhya Pradesh image, I think. And then when you blow up, this data at 23 meter spatial resolution from the second tier imaging, you start seeing the more details. There are now shades of red appearing depending on the type of crop you have in different fields. And then when you go to much higher spatial resolution, you can start seeing the individual field parcels, fallow fields, then of course the the pagdandis and all those things, and then the villages also start appearing. And of course, today large amount of cadastral maps are also digitized, especially in different states. I'll take example of Gujarat state, where the entire cadastral scale, cadastral data, the village boundary data is in digital form. And this is an example of a village in Ahmedabad Taluka, Ahmedabad district. And you can see the the survey numbers are put on the satellite image, and this matches very well with the satellite derived field boundaries. I would also like to mention one very interesting aspect over here. In the context we developed this image, and that context was related to the governance issues, especially by Ministry of Finance. So when I was in Ahmedabad, I got a call from one of the income tax commissioner of that area, and he told that we would like to take help of ISRO in addressing some of our issues. So whenever you get a call from income tax people, as such, you will be frightened. Commissioner calling you and asking some help. The only help we are all government people doing by paying our income tax in time. So he told, don't worry, what we want you is they would tell us, because a lot of people, especially the industrialists, they are making use of loopholes of income tax laws, especially as you are aware, the agriculture income is exempted in our country. And a lot of big fellows, they are holding large amount of land tracts, but they are not agriculturists per se, they are not farmers, but they are trying to offset some of the other income against the agriculture income. So they told us to survey these big parcels. You can see these yellow parcels and all, and tell us whether any kind of agriculture activity in these parcels have been done or not, because in their assessment claims they have claimed agriculture income against these fields. So for our surprise, we did this entire 1-year survey, and none of these fields were really cultivated. They were just lying idle and fallow throughout the year. And then, of course, we submitted our report, and these cases were under court, so of course they must have lost it. But this is how the information, is being used today by various agencies to make assessment about different problems which are also related with the agriculture sector. And of course, you can think about, farmer or individual level, farm level, productivity, losses, etc., etc. Opportunities are plenty. This is another very nice example I show you with another high resolution satellite which India is operating today. It's called Carter 2E. It has a special resolution of 50 centimeter. So 50 centimeter data. This is an example over Alexandria in Egypt, where you see they have fields of different shapes and sizes, especially very interesting circular fields, because they are very good in terms of agriculture practices. There will be a source of irrigation over here, and then it just turns around, and then in a circular fashion the irrigation is done. So most of the fields are all of the circular nature, and you can see the individual field parcel, the crop health, vigor within crop, within field also, how the crop diversity or health diversity is seen. There are a lot of indices one can develop about the health and the water status in the various crops. This is of course India, somewhere around Mumbai. Of course, our field sizes are small, but even then individual field parcels with different vigor of crops which also is linked with the time of sowing, etc., can also be surveyed. And many of these things are already being done by our friends. There's another, example of an agriculture field where you have different reflectivity patterns, and then of course even the horticulture fields also can be identified pretty nicely along with the fallow regions also. So if I take you to the journey of the use of space technology in agriculture sector, this journey started almost, you can say, around 48 years or 50 years of journey, when really, as I told you, we initiated this coconut root wilt disease study in Kerala, which was a ISRO, NASA, and Ministry of Agriculture initiative. And then in 1988, a project called Crop Acreage and Production Estimate CAPE was formulated at Space Application Center and Ministry of Agriculture. It was a combined project, and with IMD also for crop production estimation. And then new avatar of this was was launched in 2007 called FASL, forecasting agriculture output using space, agrometeorology, and land-based observations. And then all this, experiments, which of course FASL was basically meant, this CAPE was kind of a, pilot activity, in certain districts, but FASL was national level program. And then these activities ultimately culminated in institutionalizing these activities in India at Ministry of Agriculture. And as Director Saab was telling, there is an institute now in Pusa. It's called Mahalanovis Crop Forecasting Center, MNCFC, which is now hosted by Ministry of Agriculture, supported by ISRO. And they are now taking up, the regular inventory of various number of crops. I will show the statistics from them also about the crops, which is now being done operationally by MNCFC. And they are providing, very importantly, the pre-harvest production forecast for some more crops are added to this. This chart is slightly old. Rice, wheat, earlier 8 major crops were there. Rye, wheat, rapeseed, mustard, rabi sorghum, winter potato, sugarcane, cotton, jute. And then at national level, kharif crops are also addressed. District level, they were addressing other crops as well. And there is also an assessment done with this statistics, with the conventional the statistics which comes from the other statistical departments of Ministry of Agriculture. So if we have to summarize today, that there are a large amount of activities in, with the support of Ministry of Agriculture in terms of FASL, in terms of agriculture drought assessment, in terms of crop insurance, inputs to crop insurance companies. There is another important activity where Ministry of Agriculture has identified, certain districts for crop intensification. Then there is an initiative of Ministry of Agriculture called Maha Agritech Digital Agriculture Initiative to provide digital databases. Horticulture inventory, there was a project called Chaman, which has basically an effort to have the horticulture crop inventory at national level in select districts. And then assessment of high value crops like mentha, etc. Then of course there are also efforts, because now non-conventional source of energy are becoming important. So jatropha and a lot of other biodiesel crops, and sugarcane also is, as you know, is being used. The ethanol is also being blended with petrol and diesel. So sugarcane statistics are also very important, and that is basically provided by MNCFC as operational crop forecast. And then in the northeastern region, even the sericulture, statistics is also, and the potential for developing sericulture is also provided through these efforts. I will not go into details of it. You can find a lot of details at many places. But what is important is here that I should give you an overview, the kind of activities in which these are, the satellite data is being used. One important area is the crop insurance. And many of you are aware that lakhs and lakhs of crop cutting experiments every year are done for crop yield estimation at field level in this country. Now, how to do crop, CC sampling? That is a very challenging task. So we have developed, of course, ISRO. I'm not involved in these activities, but I was part of that group when I was in SAC. So SAC, Ahmedabad, and MNCFC and NRSC, they are developing what we call the smart sampling, techniques for setting up these crop cutting experiments based on the statistical information that how to do the stratified random sampling surveys based on the crop conditions and assessment of crop yields which are coming from the satellite data. Otherwise, your sampling schemes will not be representative of entire diversity in the cropping system. So this is very important initiative which MNCFC and other ISRO institutions today they are doing. It's called the smart sampling for improved yield assessment. Through the smart locations for crop cutting experiments, where the mobile-based apps, satellite-based data systems, as well as the ground truth locations collected through mobiles are populated on a GIS server, and you immediately get map of this CC data collection points along with the ancillary information which is filled by the farmers at the field itself. So the entire data statistics become digital with the help of this convergence of various technologies. So this is another chart which tells you about the stakeholders we are trying to address. So we have different stakeholders. So we are addressing the policymakers, especially for import-export, food security point of view, mainly the Ministry of Agriculture professionals and other professionals. They can also, this data is in public domain. They can use it. Crop insurers and farmers for settling claims, risk assessments, etc. A lot of crop insurance companies and many state governments are now started giving these contracts even to the private entrepreneurs to provide high resolution crop statistics. I know a lot of cases in Gujarat and other states where the private vendors are also generating this information. Agro industry managers, especially we have examples in Western UP, which is a large amount of sugarcane production is happening. A lot of sugar mills, they have their catchment area in terms of districts or in terms of select farmer groups. They also use this technology for making an assessment about the productivity of that region. So that is also a very key important aspect which is happening. We have done some projects for, especially for high value crops like mentha, etc., which was done on the behest of the industries. They would like to know that how much is the the acreage for the high value crop in which they are dealing. Then of course, these are some of the examples where you can see the reduction on crop acreage on year-to-year basis. Then of course intensification drives for government of India, especially in the pulse. Rabi pulses was a major thing. Many of you may be knowing that a few years back we had a real bad situation in the country about the pulses, and the prices of the pulse were rocketing very high. And then the fallow, the Rabi fallow and the other fallow areas were identified with the help of satellite data. And then those regions were basically, suggested to do the pulse, Rabi pulse intensification based on this thing. And then it worked on the ground, and definitely in next 2 years or so, the pulse prices stabilized. And of course, there are also issues related to import export, but government ministry is extensively working on Rabi pulse intensification programs of the country. So these are some of the examples of this. So these are some more examples. Anyway, I talked about horticulture crop. This is another thing where ISRO has done multiple cycles of now monitoring wasteland. Wasteland development is also a very important aspect, and especially in terms of developing biodiesel crops, especially jatropha and other crops. If you know where are the wasteland, rather than using a productive land for this type of thing, wasteland and suitable agroclimatic conditions, lot of site suitability for such type of crops is being done, which can grow on these wasteland. And these wasteland atlases are available in public domain, which are generated by our ISRO institutions. I will not go into details that how these technologies are being used. I will leave these slides and send it to you also. But at different level of crop cycle, the different observations along with the the conventional data and the remote sensing data is combined together to generate what we call as the crop acreages, which is pre-harvest crop acreage information. And then there are a lot of modeling efforts both based on agrometeorological modeling, and now people are using even the the lot of AI ML based approaches also to do the crop yield models. And then simulation models are also being combined to make an assessment about the crop yields for different important crops. Mainly, these are the crops currently being addressed: the Rabi crops, Rabi pulses, wheat, mustard, potato, Rabi rice, Rabi sorghum, sugarcane, jute, cotton, and kharif rice. So there is a complete, cropping calendar cycle is available. Some of you can contact MNCFC and Space Application Center for more details on these activities. This is an example of this, as I was talking about, high value crop assessment for mint crops in Western UP. In fact, yeah, this is Ramnagar and Badaयूं and all these districts. So, and then the status also, in terms of biomass, like poor, medium, good, and very good, that also can come because of the vigor of the crop. Of course, this is around Barabanki. Is in Barabanki district in UP. Another important aspect which is being addressed for national food security under National Food Security Mission is mapping and monitoring of post-Kharif rice fallow lands in the eastern districts like Orissa and Assam, Bihar, Chhattisgarh, Jharkhand, West Bengal, and identifying these suitable areas for growing pulses during the Rabi season. As I was talking to you, that the Rabi pulse intensification activity was helped through the observations which was available from space. So these are the details of it. I will not go into these. So this is the chart which tells you about the horticulture crop inventory. In 2 phases, it has been taken up under a program called Chaman by Ministry of Agriculture. And we have today area and production estimates in 12 states at 185 districts for banana, mango, and citrus. Then, of course, certain vegetable crops like potato, onion, and tomato. Chili in Andhra, also especially in Guntur region. Then, of course, there were certain pilot activities for horticulture site suitability, post-harvest infrastructure in terms of cold storage chains, crop intensification I talked, then creating the entire digital GIS database for these activities. Then to use this data for doing the orchard rejuvenation, because especially if you talk about orchards which are very old, especially if you go to Malihabad, Allahabad, in that region, the mango orchards, some of them are more than 50, even 60, 70 years old orchard. So using this type of technique, one can identify the old orchard because of the canopy structure and the tree shapes, and then some of these orchards can be identified for rejuvenation purposes or to grow new plants. Then there are some very interesting work was done, especially in Bihar, especially for aqua horticulture, that is known as the makhana, because that region grows this thing. And there are reports available where using the water quality indices, eutrophication indices, and certain other parameters, some of our friends also identified water bodies which are very good for aqua horticulture purposes. So these are the statistics for this Chaman program. I will not go into details of it, but these are the 327 districts were selected for doing the inventory for horticulture crops in India in 2 phases by Ministry of Agriculture and Department of Space. Of course, crop yield modeling is a very complex and complicated task, but it is also being handled by using different approaches, crop modeling approaches for yield models. And then we have today capability to produce, the regional level assessment of, let's say, this is an example of wheat grain yield. And as you can see, it depends on large amount of inputs also. So Punjab and then Haryana, and then of course some part of Western UP will have much higher yield at district levels as you go towards Bihar. And then of course these are the high yielding districts of Madhya Pradesh in terms of the wheat yield. So we can capture the spatial variability of yields also by combining various indices with other agromat parameters and do various kind of empirical, semi-empirical, and analytical modeling schemes. Then here, disaster is another important aspect where the post-disaster recovery and assessment is a very important issue, and especially for farmers. And now with the Pradhan Mantri Krishi Fasal Bima Yojana coming into foray, this becomes a very important activity, and it also supports agri insurer companies also, because they also want to know these inputs for settling the claims of the farmers. So especially, operational and periodic drought assessment, anyway, that is I just told. But in terms of extreme weather events like cyclone, hailstorms, heavy rainfall, impact assessment, I can tell you that almost near real time, suppose 2 days back, if cyclone has struck, the next day onwards, when the skies are clear, or if we have the, let's say, microwave data available, we will be able to give you a map where you can make the damage assessment to the standing crops. So that type of, ability exists today from space. And then, of course, assessment of impact of biotic stresses also, like in terms of pest and disease. Recently, I think 2 years back, locust was or last year itself, I think, locust was a very big issue. And a lot of people in space community, as well as along with agriculture community, did a lot of modeling for warning about the locust, possible, infestations. Rice residue burning, I will come to that also. This is also very important aspect, and now we are into that season as we are getting into October, end of September and October. All of you sitting in Delhi will face that issue. And I also, Government of India has made a commission to manage the air quality of NCR, and I happen to represent ISRO as a technical member in that, and we are providing a lot of space-based inputs about the crop fire events, about the dispersion of these pollutants, as well as identifying some of the intervention schemes, like in Punjab they are talking or convincing farmers to go for DSR rice, direct seedling rice, compared to the puddle rice, because the crop duration is shorter, water management is much better, and then it is harvested much earlier than the puddle rice, so that they have more time for the next crop to grow. They need not burn the residue. So that is another important aspect. Drought, I told you that now we have this capability to view the entire country and then generate the time series information about the vigor of the crop. So suddenly, and the drought is a slow moving disaster. So we can identify the anomalous regions, with respect to 5 years average, indices, and what are the anomalous regions or districts where the droughts are sitting in. So vegetation condition assessment can also be done at national level. And a lot of inputs are going for this initiative of crop insurance. We are providing geospatial support for crop mapping and area discrepancy analysis in the insurance units, prevented failed sowing information, then crop loss due to natural calamities, crop cutting experiment I talked about, in terms of assessing the yield of the farmer. And then a lot of farmers will be, claiming, some yield, and the insurance will, fellows will tell some other yield. So somebody has to broker a deal between that. So there are now a lot of what we call the insurance broker companies are also coming up, which are using the technology to prove their claims. And then, of course, agriculture risk information for products for rate making. The insurance rates are also very important, because if you are living in an area which is vulnerable to multiple hazards, the insurer will ask you higher premiums on your policies. And this work in India is yet to be done. It is very, very much done in Western countries, where if you are living in a vulnerable area, you have to pay higher premiums for your insurance policies. But in our country, as on date, this rating system is not there. But most very likely it will come up in future. And there you will see the use of risk assessment using the frequency of hazards and frequency of disasters, which can be assessed over 10 years, 20 years using these data sets. Now, drones are also becoming very useful in assessing, the highly localized crop damages. And one of our sister institutions, especially the Northeast Space Application Center, they have the expertise in, operating various type of drones and sensors in mapping the parcels, the crop parcels at the farmers field level for various kind of crop damages, either due to rainfall or hailstorm, or maybe crop in pest and disease infestation. And this type of maps are generated or as a pretty rapid, assessment service. This is the same example in detail. Another important aspect I would like to emphasize here before I close is the power of time series data. Today, we have from space around 20 years of time series over India in terms of vegetation cycles. So what I show you here is the vegetation indices. So more green is the healthier vegetation. And then if you are in the lesser green, like Rajasthan and all, the vegetation health is very, very poor. And then I show you a time series from May 2012 to 17, 5 years time series. Of course, 20-year time series is also there. This tells you at a location, suppose this green location is at a pixel level. That means at 1 kilometer at a 500-meter scale, I have this 20 years of cyclicity. So you have a crop, which is basically now sown, it matures, and then it gets harvested. It's a wheat rice system over here. So then you have this another rabi crop grown. Then like that, you can count the cycles and then study this data for various purposes like crop rotation, failure of crops, then also for making assessment about the impacts of climate variability on the crop growth. So this type of climate scale 2 to 3 decade data from space is available. And I think a lot of people, those who are dealing with the agriculture statistics and economics, would like to explore this data. This is not at all explored. Very few people are working on such data sets in terms of generating statistics over long periods about various issues which are related to agriculture statistics in this country. There are newer technologies are also coming. One such technology is known as the hyperspectral remote sensing, where the individual field level you can identify the health of the crop, the water stress in the crop, because we are now sensing the very fine subtle changes which are caused in the electromagnetic spectrum because of the water stress, because of the the pigment level variability, or maybe because of the pest and diseases, or even in terms of various biochemical elements also up to certain level people are able to go. This is one example. We had a aerial survey with the NASA Everest NG. They brought there this hyperspectral instrument. We flown at various fields. So you can see these different fields. Very interestingly, some fields you will see here pink in color. These are all the green fields, but these are fallow fields. But these are all pink fields. Now, pink fields are what? How do you have fields which are pink in color? So basically, this is over Guntur, Kurnool in Andhra, and this is a chili growing region. And you see that a lot of chilies are harvested from this area, and they are put in the fields for drying purpose. So this is the field photo, and this is how it looks when you fly from space. So you can also make an assessment that how much amount of chilies are lying for drying purpose, and some kind of estimation, smart estimation about the chilies around the villages in Kurnool and such type of areas also is possible. This is about the crop residue burning, few last slides. So here you can satellite data tells you which are the fields where they are burning. So these bright dots, these are the fires, local farm level fires, and then how this the smoke, it travels towards Haryana and Delhi, because in this season the winds are coming from Pakistan and going towards Bihar, because this is the wind reversal season. After monsoon, the winds will reverse, and that is why this lot of smoke which is getting generated during the Kharif residue burning events, it basically comes towards Delhi and then goes all the way up to Bihar. But of course, with a lot of intervention, Supreme Court, government taking initiation, persuasion of farmers, we are observing that since last 2 years, the events are reducing, but still, we have to see this year what happens. Of course, there are concerted efforts of various kinds. So one such effort is, to convince farmers in Punjab aggressively. They are convincing farmers to go for, change the cropping rice practices. So they are going for the direct seed DSR rice and the puddle rice, which is a normal practice. So I had a chat with a lot of experts. They told me that the water consumption is almost 30% less. The crop is grown at around in the first week of June compared to around 20th June for puddle rice. It will be harvested earlier, and then farmers will have enough time to prepare their field for the next crop, that is the Rabi crop, and they may not burn in that scenario. So this year, almost, you can say almost 1/3 rice area in Punjab. And this is the work done by our Punjab Remote Sensing Center. So what you see in yellow color is the direct seed rice area in Punjab. And then in blue color is basically the conventional puddled rice, this thing. So we are seeing some fruits of, counseling and interventions of farmers. Some practice changes are happening. In fact, all of you are aware, as such, Punjab is not an ideal place to grow rice. But because of the policies which are related to, the crop pricing regime, especially what you call as the current, controversies, Punjab and Haryana are the largest beneficiaries of the fixed price regime, and especially for wheat and rice. Farmers are growing only, they are basically concentrated on these rice regime. And in that process, a lot of biodiversity issues also there in Punjab. But this is a new statistic. This is for 2021, this is July data only, where good amount of area is under DSR rice, and probably it may address some of the issues which are related to, crop residue burning. So essentially, to conclude, in terms of governance, in terms of providing information to various stakeholders, and to meet continuous and demands-based, information for planning, monitoring, evaluation today, space data is being used for various programs of Government of India, including DGRI, PMFBY, PMKSBY, and then Amrit which is under urban development activities, Swachh Bharat, and many others initiatives. And many of the ISRO institutions, especially National Remote Sensing Center, Space Application Center, they are all involved along with the user ministries in generating this information. I will not leave without, just doing an advertisement for my institute, which is Indian Institute of Remote Sensing and Center for Space Science and Technology Education. We provide a lot of capacity building initiatives for different ministries, the individual capacity building as well as the institutional capacity building, to use these data sets to train your manpower in terms of understanding the products, and in terms of using these products for your problems of your own statement. You can also request for a customized training program which may be suitable to your officers, or we are also doing the similar ones for various other governments of different countries here at IIRS Dehradun, as well as SESTEP is basically an institution to provide capacity building in the broad field of space science and technology education, not only in India, but in Asia and Pacific region. It is a UN affiliated institution, and it has a very good visibility in the international arena as far as the space education and training is concerned. So we have a host of training programs for decision makers, for senior functionaries, training programs for middle and working level professionals, and then for training programs for trainers like teachers, university teachers, school teachers, and various other segments, where the training toward the trainers is the basic issue. So I'll not go into details of it, but I can provide this information to you. So what's the way forward? The way forward is currently at national level, we are doing inventory of few crops. We need to increase the inventory and number of crops which we are assessing through remote sensing, and then through conventional means. These assessments are being supported in terms of their accuracies. We have to have models for better field yield forecast, considering both abiotic and biotic factors, infusing higher technology into government crop insurance programs, which is the initiative, which is a very important initiative in digital agriculture framework. Improving drought indices, sustainable agriculture is very important. People are now talking about carbon credits and stuff like this for farmers, those who are practicing the organic farming. So this will come up in a big way, because there is a huge market for the carbon credits, especially which are linked to the agriculture emissions in India. India also a big emitter as far as the agriculture activity is concerned. In terms of course, the biomass will sequester the carbon, but the other activities like irrigation, tractors, tillage, all these things also produces large amount of emissions. And most importantly, most of this information should be there on geoportals in an exclusive fashion, which is still lacking, which provide a holistic view of the current agriculture state. In season current statistical information should be provided almost in near real times to policymakers, as well as, if possible, to farmers, which is very challenging task at providing this information at that scale. and basically to understand issues related to the new threats which we are encountering, especially which are related to the climate variability. So with these words, I would like to thank each one of you for listening me for almost more than an hour or so. Space is working for humanity and touching lives in various sectors. We are doing a bit, whatever we can do, but I think we need to do a lot with the association of other scientific community, NGOs, and various communities on the ground. So it does give some satisfaction to us that we are in a way able to touch various segments of society, but we have still a long way to go. And I can tell you that in next 5 to 10 years, we will see a revolution of what we call as the digital information coming from various platforms, which will change the shape of Indian agriculture. Thank you, sir. Thank you very much.
Thank you, Dr. Chauhan, for a very, very interesting and educative lecture. You have not only shared the space advancement in space science, but also the application of space science in the field of agriculture. Very elaborate. Almost all the aspects you have covered, and we can see there is a lot of potential. We have not actually used the potential which is there to use the this remote sensing and space science for real-time monitoring, inventory mapping, resource, let's say the monitoring, all kinds of application, crop insurance. I mean, it's one area where we can really improve the effectiveness of the program and preciseness of the program, particularly the this crop yield estimation. That's very, very important. Otherwise, it takes a lot of time. So thank you very much, Dr. Chauhan. We have comments from different, you can see, from different participants. They have really appreciated your thoughts, your lecture. And still you can see for economics, 86 participants, they are there. It means a lot of number, they have interest. There are some interesting questions. One is, of course, related to, maybe you would like to respond. One is the, let's say, the this availability of real-time data in public domain. The satellite images, whether it's there or it takes time because a lot of sensitivity is involved. So and second question is basically monitoring of groundwater and accuracy of the rainfall, how much, let's say, there will be the precipitation. So whether it's possible to have that kind of information. Yes.
So just to respond to this first aspect, which was there on real-time data. Almost. So this is a big question, which is basically being addressed by a lot of people nowadays about the availability of satellite data from Indian satellites, as well as I will also address the international satellite data availability. So there is a historical perspective about the mapping, surveying, geospatial and satellite data availability in India. In fact, for very long time, in fact from the British time, most of these information have been covered by certain rules and acts, and which basically hinders and restricts the dissemination of this information to public in large. So there are such kind of rules are there. But now recently, Government of India has taken a new initiative to increase the private partnership in the broad field of space science and geospatial technology. So policy guidelines have been circulated to amend the previous policy guidelines and new guidelines which are very flexible in terms of assessing and getting these data sets from various entities and generating, and also doing private sector based mapping, like drone based mapping and all. Otherwise, if you do go and map, police will catch you also. There are draconian rules of there.
Certainly.
So now with these policy guidelines in circulation and consultation process for new policy is in it is in offering, and I hope that very soon all this activity will be very much relaxed, and not only government sector people, private sector people will also be able to do a lot of these activities without much of restrictions. Now, space data also has this policies in India, especially, the space-based data is cleared to private sector or to public consumption after what we call as the Ministry of Defense clearances, because there are sensitive and vital installations and stuff like this. So this policy, this is called the new remote sensing data policy. This is also now is being revised, and this policy guidelines again has been circulated. And very soon you will see that up to 1 meter spatial resolution data from Indian satellites collected over India will be made available to public free of cost, and private operators will also be able to receive this data by their putting up by their antenna systems and all. Only there will be certain restrictions for very high resolution data, which is less than 1 meter, and clearances, etc. also will be eased out. Now, this is the Indian scenario. So today there are certain difficulties, but you can get data still, especially in the government sector, from the only distributor of satellite data in India today is National Remote Sensing Agency, Hyderabad. So you have to contact, there is a National Remote Sensing Data Center, NDC, which is the custodian and the whole sole distributor of satellite data over Indian territorial jurisdiction. So even the foreign operators, those who are having foreign satellite operator, they are operating, they are not Indian operators, they are collecting satellite data, but if they have to sell this satellite data in India, people has to go through this National Remote Sensing Agency only, even if they have to buy private operators data. So this is the rule today, but this rule is very soon likely to be relaxed. And there are international satellite data like NASA data and then European satellite data of coarse resolution, 10 meter spatial resolution Sentinel data is publicly freely distributed by these agencies. You can go and download today's Sentinel data if that overpass is there after 6 hours, free of cost at your computer.
Thank you, Dr. Yeah, it's, I think regulatory aspect is also equally important for this digital information, as well as this use of, let's say, the like drones and other things for mapping the fields, or maybe some whatever work is being done. Another question is related to the startups. So you have already answered that. There are a lot of scope.
A lot of new young startups are coming.
Yeah, youngsters and private sector participants.
But a lot of IIT graduates, those who are computer scientists,
they will be amazed to see, I guess.
Yeah, they will be amazed to see they have interest in agriculture nowadays. They don't want to become farmers, but they want to monitor farmers.
Farmers. Yeah, there is one, I think you must be knowing that there is one company, actually SkyMet. So they are in the weather information.
Yeah, they are weather forecasting.
I mean, they are not charging, but still they have some advanced information. Another question is related to whether once you have the information from remote sensing, whether some kind of ground level information, what you call ground truth,
it is required,
or it is now.
No, actually, I did not tell that because we did not talk about how the information is generated. See, today also we have to depend on ground truthing for the satellite data, especially in terms of accurately classifying this data. And only thing is that we need limited ground truth now. Extensive ground truth is not required, so limited ground truthing is there. And today we have smart ways of obtaining ground truth. The scientists need not go. You have mobile phones, smart mobile phones with most of the farmers also. You can engage with that community. They can send you a geotagged photograph of their field, showing that which crop is at what location. And then with that information, if you have this crowdsourcing apps, hundreds and thousands of farmers can join with you, and then immediately you get this ground truth information from farmers for classifying these satellite imageries in terms of the crop cover.
Yeah, that's quite possible. So I think this is all what they have. But if somebody has some more questions, so directly email to Dr. Chauhan. But one area, Dr. maybe you would like to benefit, not now, maybe sometime we'll be in touch with you. So one information, partly you have covered. Actually, the mapping, the images of chilies harvest, no?
Yeah.
So is it possible we can do the imaging and look at the some kind of assessment, how much product is coming in the market? That is mapping, mandis, all those things. So that is one area, because that is
Economics.
what we actually see in economics and agriculture economics.
No, I think this is a very good point, and I have been
Yeah.
talking to some of my friends and telling them that until unless you integrate the mandi and the rates along with this information. See, I'll give you a classic example of onion. So onion glut,
Yeah.
some problem is there. So if a farmer in Gujarat knows in advance that in Maharashtra there is lot of onion acreage is there this year, because they grow slightly later, I think, then they can have a smart assessment that this year in Gujarat you need not grow so much of onion, the market prices are going to crash. So this type of
Yeah.
market intelligence and economics, with this data, if we associate, the value of data will go multifold, and then for people can grow some other crop where the likelihood of crashing the prices are not there. So I think these are the new dimension which we need to attach with these data sets. Your point is
certainly, Dr. I mean, we have this kind of now responsibility from the ministry, that we have to get information what is done by this crop forecasting center, and then follow the market information, and then try to see how the prices they are going to behave in the let's say days or months to come. So that is the basic thing. So thank you very much, Dr. Chauhan, for your time and the information which you have shared, and certainly we'll be in touch with you, and we'll have a program, something. If your institute can collaborate, we'll be very happy. Otherwise, you can suggest somebody else, whether this Ahmedabad or let's say the Hyderabad Institute, they can collaborate. For some of the work, actually, we'll identify it and have a program on this, and would like to benefit from your experience, the work which you have done in the field of agriculture. Water, of course, will be one. Market will be another thing. So now I request Dr. Rajni Jain to propose a formal vote of thanks. Thank you, Dr. Saab. Really appreciate.
Thank you, sir. Thank you, Doctor. Thank you, Paul, sir.
Unmute, Mrs. Jain, unmute, yeah.
So good afternoon, everyone who all are present here. Honorable Chief Guest, Dr. Prakash Chauhan ji, Director IIRS, ISRO, respected Director Sir, Dr. Suresh Palji, and all the participants. It is indeed an honor for me to get this opportunity to thank you all, the esteemed guests, on the occasion of this 4th webinar for celebrating Azadi Ka Amrit Mahotsav. On behalf of our institute and on my own behalf, I extend a warm thank you and my gratitude to all the esteemed delegates for this webinar, for their presence and their contribution to make this webinar a great success. I extend my gratitude to our Honorable Chief Guest, Professor Prakash Chauhan ji, to take out time from his very busy schedule and share his wisdom and knowledge. Sir, you have taken us to the exciting space journey of 50 years, as well as applications of space technologies in agriculture. You have shown us many dimensions of this space data in agriculture, and I think all the economists and social scientists, they got an excellent food for thought for their research efforts in future. So thank you, sir, for your inspiring, encouraging, and motivating excellent lecture. I'm sure it will be helpful to enhance the use of spatial technologies in NARS, National Agriculture Research System. This, with your permission, sir, this lecture will be available on Facebook for some time.
Sure.
Those who cannot attend this. And I would like to have a special thanks to our Honorable Director, Dr. Suresh Palji, for providing immense support and guidance to make this webinar successful, and also moderating this today's session. I thank all the participants and my colleagues for their active participation. We had, ours is a small institute. We had nearly 20-25 scientists and technical people here. So they all participated, and beyond that, other economists and social scientists from entire NARS were with us. And I extend my gratitude to this AKMU team, administration and finance, for making this webinar successful. finally, I would like to thank everyone once again for making it a great success. So thank you one and all. So I would just like everyone to switch on the video so that we can have one photograph of the gallery view. All NIAP scientists. So please, and I request everyone to be there. Dilip and you can take a
picture.
Yeah. Thank you, sir. Thank you once again. Thank you, everyone.
Thank you, sir. Thank you. Bye.
Thank you, Dr. Chauhan. Thank you very much
Thank
for
you,
your
sir.
time. Yeah, thank you.
you.
We'll be in touch. We'll be in
Sure,
touch.
sir. Sure.
In the beginning.
It's a pleasure to meet all of you.
Yeah, thank you.
Yes, sir. Thank you.